Okay, before we continue and before we get lost into the type of algorithms that I'm going to go through in the rest of the lectures on reinforcement learning, let's see where we are. What are we doing? What is the map? What is the big picture? The reinforcement learning algorithms, you can divide them into two major classes. Model-free, where you are not modeling the transition probability of your environment. So you just interact with the environment, but you don't model your environment. And then there are some model-based. For model-based, if you know your model, this is perfect. This is a perfect scenario. In that case, we are going to see an example of an algorithm for solving Go, chess, and shogi later on. So we are going to cover this. For when you're learning your model, you're going to rely too much on an approximation to your environment. This is a good idea. You try to learn the model. It's going to give you a more complex reinforcement learning framework. But these days, at least up until 2020 and 2021, they are not mainstream. Maybe in the future, things are going to change and people are going to start learning the model and do model-based reinforcement learning. And there are actually some works that are trying to do so, but it is not yet mainstream. So we are not going to cover that. And for that, I'm going to leave it as research, as a research topic. But we are not going to cover it in a course. What we have been doing so far was model-free. We don't write any models for the environment. It turns out that these algorithms are actually easier to code. We started with Q-learning. We covered deep Q networks. I'm not going to cover the rest of the papers that are getting cited here. So we are not going to cover that. This is going to give us a good flavor of what type of algorithms are going to deal with Q-learning. So we did deep Q-learning, and we played Atari with it. And then we didn't want to let go of the Bellman equation yet. So we covered deep deterministic policy gradient. So we covered this paper, we covered this. Alpha 0, we are going to cover in the future. But then when we went to this regime, to policy optimization, we are sort of letting go of the Bellman equation. Not totally, we are still using it, but we are relying on maximizing the expected return or maximizing or minimizing the expected cost. We cover TRPO, Trust Region Policy Optimization, so far. We actually covered policy gradient last session, and we are going to cover these two other methods. This one we are going to cover today, and this one later on, next week. But this is the landscape. I don't want you to get lost or get confused of what we are doing, okay?